Hello, citizens. How you doing today? We have a good selection of people today. Can you hear me? Am I live? We got the Mamgoosian in the house. We got Alex Knott. We got Raphael. We got Not New Fitting Dreamer. We got Zach Sheeran. We got our Ann Smith. Vishal Chauhan. We got Book Nerd. Lop Kabor as always. Cesar Zamora is here. Good to see everyone. Tell us where you're from. Cough at your throat not being cleared because you woke up 10 minutes ago. If you're like me. Get a drink of water. How you doing today, my fellow citizens? I got a small little improvement to my setup today, which you cannot see, but I actually rigged up a desk here so that instead of doing what I usually do when I produce, where I have to like lower my keyboard and then very carefully put the keyboard on top of the keyboard, as it were. I don't have to do that anymore. So I got a little keyboard here. My one problem is I've got two computers going, so right now I've got the mouse for one and the keyboard for the other, which is gonna have to change. But yeah, that's good. Housekeeping rules for today. Let's make a little thing. Hey, that's dumb. Hey, Radka. How you doing? Hey, Book Nerd. That's weird. Okay. Not allowed to. Hey, Laura. So I was conferring with Evelyn yesterday about the best way to move forward with creative projects. Because as much as we got through like a month, it wasn't even a month. It was like we got through 3 weeks yesterday. It's just gonna take too much time, I think, to do it the way we've been doing it, like systematically going through the history. So what we have decided, as I have alluded to, that we're gonna actually use the subreddit. So you can see in the announcements tab, Pilly Pie has been nice enough to, I think, I don't know if she's done this yet. There is going to be, or there already is, a mega thread on the Reddit. And the way mega threads work on Reddit is that they're basically like their own little subreddit. So like within our own subreddit, there will be a mega thread of creative projects. You can post any creative project you want there. Anything from the past several months that you've done, your best work or whatever, or new things. And then the cool thing about Reddit is like even on a thread, you can vote up, different people's posts and like comment on them and stuff. So this way we can get the we can get snapshots of like what the community thinks are the most important community creative projects, and then every week I can just do the top ones until my time is up, and that'll be the cutoff. So that's democratic. Seems fair to me, and it also I think it encourages excellence. Yeah, no, they don't have chronological order. We're not doing chronological order. We're gonna do by order of, like, it's gonna be on the one thread, unless that mega thread gets too crowded, and then we'll make like a second mega thread. But you post on the creative projects thread, and then you upvote and downvote on like the comments on that thread, and then I'll sort of read from top to bottom. If you have trouble figuring out, you can ask a mod to help you. Like the creative projects, like I'm not saying abandon the creative projects on the Discord by any means. Like that's still the place to like just like post your stuff to the community, and like get feedback and like real-time response and like all that stuff. Like that's great. Just for the purposes of like me reviewing stuff, we need some sort of filtration system, you know? So that's what I'm gonna do for the streams. But like for like, hey guys, here's this thing I made that I don't really, it's just fun. Let's see. Responses. Yeah, Laura, I would say like whatever you can put as many things up there as you want. But like whatever you've done in the past little while that I haven't seen, that you're like, hey, this is like a thing I want Tim to see, put it there. Yeah, same. What with the posts that we still have left, like on the like backlog of the thread. Yeah, like I understand that this like the shift is a little annoying as a start. Like because you've already posted a bunch of things, it's annoying to like go back and double post. I get that. And that's my bad for like being away so long. But I've sort of put myself in a position where I don't know. I want to get up to new things that we're making now, right? Because like I can feel that unless I do like creative projects for like another 8 hours this week or something, we're gonna be like on this constant backlog where like I'm not seeing people's new stuff and like responding in real time and like able to like correspond and critique like as you're actually working on stuff. And that's what I'd really like to do, it's cool to go back into the archive, but it's also cool to like be doing this in real time together. So oh yeah, we had a Nobel Prize in physics today. It was Penrose, Gez, and what's the other person's name? Something. Gerson? Is it Gerson and Gez? Their names are so similar that I can't remember which one is pronounced exactly. But Penrose, it was for sort of cementing the place of black holes in theory of general relativity. And Gerson, is it Gerson? I'm gonna look this up. Genzel, that's it. Genzel and Gez. For actually like discovering the black hole at the center of our galaxy, which we have now imaged and stuff. I presume like yeah, this is probably because of the Event Horizon Telescope picture, right? That now it's like really firm. Black holes definitely exist and are at the center of the galaxy. So the Nobel team is like, hey, this is the year. It's crazy how long like people wait around wondering about Nobel Prizes. Like when was Penrose's work on this? It was like the 60s or something. All right. I think that's all I've got to. I think that's all I've got to say about that. Yeah. Nobel Prize in Physics for women. It's Andrea Ghez is the woman, right? I keep forgetting their first names because I didn't know about them. Yeah. Reinhard Genzel, Andrea Ghez, and Roger Penrose. Yeah, Penrose is still alive. He keeps going on podcasts. Like I keep seeing him around the internet as on like he was on I think he was on Lex Friedman's podcast. He was on like Joe Rogan a little while ago. He's got some strange ideas, Roger Penrose. He's a quirky guy, and he's always kind of been like on the edge of like he's always really pushing the boundaries of things. So he seems really wedded to these like ideas of like consciousness emerging out of quantum interactions in microtubules inside of neurons, and that seems like really quirky and not super well sourced to me. In fact, like his whole thinking's, to me, as you know, obviously I'm not an expert on consciousness either, but his thinking seems a little muddled in that score. But yeah, still doing stuff. Penrose said he's glad he didn't get it earlier. Like if you get the Nobel at the start of your career, then everything's a failure after that. Yeah, it's like when you're a YouTuber and you get one huge viral hit at the beginning of your career, and then you're always chasing that forever. That's relating myself to Roger Penrose. What am I doing? Yeah, Raphael, so next Monday we'll try we will launch the Reddit mega threads technique, and we will see if it works. It might bomb, and then we'll go back to Discord, but be a thing to try. Aloha. Okay. Someone won the Ig Nobel and then the Nobel. Who is that? That's a curious tale. So should we try doing some? Yeah, I still can't get the Twitch chat to work. So I apologize on the Twitch chat. I did improve my green screen setup. Remember how I used to have these white bars over here on either side, these white walls? I no longer have them. I cut apart my green screen and made it longer than it is, wider than it is long, because I didn't care about it going under my feet. Better use of space. Now I have full range of motion. Yeah, let's see. Should we go? Oh, that's the wrong keyboard. That makes sense. So we're gonna boink, boink, boink. Is that us? Hey, look at this. We're over here. And then over there is the Mamgusian. Is that, can you see Twitch chat today? Okay. That is today's stuff. You can still see you, but you're a little bit, I mean, you can also see you right here because that's where you are. I'm going to put that over there. Get this over here. This year's Nobel Prize in Medicine was awarded to researchers who discovered the hepatitis C virus some 30 years ago. Better late than never. Yeah, I mean that's how it always works, Book Nerd. Like, yeah, the Penrose thing was like 50 years coming, or more than that. I'm not even sure. Sir Andre Game. What did he win? What did he win the Ig Nobel for? I love the Ig Nobels are great. Okay. Here's what we're going to do. We're going to minimize you. We're also, the question is, can the computer run Blender? Well, oh man, I've got so many things open here. Can the computer run Blender effectively while also running the sound program? That's sort of the question we're going to have to figure out, because it's gonna be a little tricky, but yeah, I'm gonna open up Blender. I'm gonna show you what it. You can still. Oh, does it not work anymore? Oh, it does work. I just turned it off. Yeah, so Raphael, you'll have a good time with this. As a Blender aficionado yourself. Yeah, I don't really know how this computer runs this particular file, so this might crash and burn. Because I mostly did this work on the laptop, which has a a poorer CPU but a better GPU, and I'm using Eevee, which is the renderer within. It's more like a gaming engine renderer within Blender. Like there's a really photorealistic one that mostly uses CPU and takes ages, and then there's like a fast one that uses like ray tracing in the GPU and like materials tricks and stuff. The way games do to like render frames in real time. Um, and Yeah, so I've been doing this work on my GPU and I'm or on my computer with a good GPU, and I got to see if it holds up or can be rendered on the one with a good CPU, because this file's been known to crash. We'll see. So we'll click on it, and then we'll see if my audio starts popping and doing crazy things. Oh, hey, look, we got something. Okay, all right. I haven't opened this file in a while, so let's see what we're looking at here. Oh, well, that's weird. Uh, Maybe we could get it to render again. Hey, look at that. You see that? Well, that's kind of interesting. What, you might ask yourself, are you doing, Tim? What exactly have you got going on? So I've been attempting to make, so this is for field vibrations. I've been attempting to make models of fields. So this is kind of, I don't know, it's really weird. It like I've built it up to this point, and now I'm like, does this? I don't know if this really illustrates what I'm trying to illustrate. But this, what you're looking at right now, is my attempt at visualizing frozen in time a fermion. This is what I like, to the sort of best of my mental abilities. This is what a fermion looks like. It's got this kind of like, it's this field made of bits. So you've got on like at each point you've kind of got an up and a down, and it's in this crazy superposition of combinations of up down down up, like big like qubit entangled messes where all the like classically this field would like every one would have a every point would have a firm state. It would either be up or down, down or up, like a computer hard drive, right? Like ones and zeros. But quantum mechanically, it's this like big mess of not only different weights on the ones and zeros, but like those are entangled in different ways. So you can have states where this bit is entirely one, but only if this bit is entirely zero, and this bit is entirely zero, but only if this bit is entirely one. And you have that for like every point on this field. And then those weights also have different phases. So what a phase is you can think of positive and negative as the beginnings of an understanding of phase. Um, but phase really works in the, so if you can talk about the magnitude of a number and the phase of the number. So the magnitude is how big it is, and the phase is where it is, sort of. So in the classic world of positive and negative numbers, you have two phases. You have positive and negative, right? Um, Positive +5 and -5. The magnitude's 5. The phase is plus or minus. In complex numbers, which is what quantum, like all quantum mechanics works in, you have a circle of phases because the complex numbers are a 2D plane. So you'll have a number that has some magnitude. So 0 is at the center of the plane, and then you have some magnitude. You go out into the plane in some direction, like a vector, and that is the magnitude of the number, and the phase of the number is where around that circle it is. It goes from 0 to 360, right? And then it loops back on itself. Simultaneously, there is, because of a quirk of human perception, a circle of hues that we experience, from red to orange to yellow to green to blue to violet to pink to back to red again, because of a quirk of our eyes. So what I'm doing here is that I'm representing phase, and this is a pretty common thing to do in physics. I'm representing the phase of a particular contribution to the overall state with colors. So this, the phase of red, of like purely positive might be red, the phase of purely negative might be green, and then these things in the middle. So that allows me to like circle from one to the other because phase loops back on itself. So you need some way of visualizing it that loops back on itself. There are some problems with this. One of the main problems is that to actually simulate a quantum field would take more computing power than is present in the universe. So you gotta do like you can't like with this thing. Like I tried doing like a really accurate like 1-to-1 simulation. Like here are the equations. You can do that if you restrict yourself to one dimension and have about 15 points. But the computing power to do it properly, at least in the naive way that I was doing it, goes up exponentially with the number of spatial points you consider. So if you add one more point, you double the time it's going to take to figure out what to do. And so if I want something like this that's like 50 points by 50 points, it would take far beyond the lifetime of the universe to like compute and render that. So I think I could probably, like, if I knew more about machine learning, I could probably have solved that with like smarter machine learning techniques to like approximate stuff. Yeah, hold on. Let me because this stuff takes forever to render. I'm gonna show you some stuff I rendered. This was like, oh, this is Acapella Science. There's a lot of this that I put on Twitter, I believe, a little while back. Let's see if I can find it. Is it Blender renders, Blender projects? What's this? What are we looking at here? You got this? So this is weird. This looks weird. I'm not entirely satisfied with it. I was trying to like move the camera in and out to get some idea of what's going on. Let's do this from the beginning again. Yeah, like right now it still feels too jolty to me. So it's like, and I made the camera movements too crazy for one thing. But you can see, so it's this part in the middle here, this part that has sort of coherent color, that's a particle. That's what a particle is in the world of fermions. It's like a point of coherent color and coherent phase and coherent magnitude. The particle isn't at any one point. It's this whole wave here. It's this whole like bundle of stuff. Alice is off the hook. Why is Alice off the hook? I mean, Alice is off the hook, but why does she think that? Yeah, so the things I'm not really satisfied with right now are that like this might give someone a seizure. It would be nice to have these colors not be so erratic, so they can. So I'll show you what I did with the boson, because the boson's a whole different system. This is the fermion. Oh dear, what a lot of things. Where's the boson? The wave packet. Wave packet camera movement. Is this it? This might be it. Oh yeah, that's is that? No, that is. I feel like I need to slow this down to halftime. I think I rendered this way too fast, but yeah, I might have. Maybe I did this better and make it wave packet move. Is that it? Yeah, there we go. Okay. So this is what a bosonic field looks like, to my knowledge. You can tell I've made it a lot less binary, a lot less zeros and ones and specific points, and divided up into a grid, because that's what bosonic fields are like. Fermionic fields, which are matter fields, are very binary. They're 0 and 1. They're up and down. They're left and right, whatever. Force fields, or bosonic fields, seem to have an entire range of motions instead of just being locked at 2 points they can choose between. So this field, you will notice if we do a cross section through it, can be all sorts of things. And this can be more of your standard, like wavy looking field. But is it a wave modifier with bumps on one end and a wireframe on the other? Oh, Raphael, you will see what this is. And no. You could probably do this with, you could probably get something like this with a wave modifier, but we're going next level for this stuff. Um, so like right now, I'm just going to try to explain the physics. So what would happen with a, when you, if you think about a wave, like a wave along a membrane, you could like you can think of this as a quantum membrane, um, a bosonic field. So normally, if you wave a membrane, it has a definite position. It has a definite way that it's waving. Um, in if you take a snapshot of a drum or whatever, it'll be vibrating like this, and then like this, and then like this, and whatever. Um, a quantum field, because it is quantum, can be in a whole bunch of different states of vibration all at once. And if you get those, if you get those states of vibration all just kind of random, that's just the vacuum. That's what we think of as nothing, no particles. It's not, there's not nothing there. There's a field there, and it's waving in all sorts of crazy ways. But it's no particles. It's just this region out here. Nothing doing, kind of weird. In the middle here, where it's, once again, it's the coherent waving of a particular part of the field that makes, it gives you this particle like structure to it. So here you've actually got like a, yeah, ask me questions, please ask me questions, because whatever isn't like, whatever is confusing, I want to know about it. I'm like really struggling to find any this is why this video is taking fucking forever. Because I'm taking, like, I'm not convinced that I think this is a pretty good, like pretty robust a pretty robust explanation of waves of quantum fields, or a pretty robust not explanation, like way to visualize quantum fields. But I really don't know for sure. Why are all the waves out of phase if they're coherent? Well, like talking about coherence, Sean, I'm gonna have to talk about a particular point in space. So, like the answer is in this section they aren't truly out of phase. There are, like, really what's going on here is that all the phases except basically two of them are going to cancel out at any sort of slice through here, and you're just going to get like sort of yellow on the top and blue on the bottom, say, making this kind of standing wave pattern. So that's not the same as being out of phase. It's just got two phases that are superimposed. But at like in the rest of it, they're really just a complete jumble that cancels out. Yeah. So but the weird thing is like quantum field theory really takes place in such a high dimensional space that anything we like put down here in 3 dimensions is going to lose some details. So the thing is, usually, like if in quantum mechanics or even in standard wave theory, so here you've got a positive, like say blue is strictly positive. Here you've got blue being a wave like this that's going up and then down and then up again and then fading out over there. And here you've got yellow, a wave of the absolute opposite phase. It's negative, going down and up and down. If you did this classically with waves, these two would exactly cancel out. You've got a positive wave, you've got a negative wave, bam, they're gone. But they're out of phase in two different ways. Not only are they out of phase in physical space, like this one's up while this one's down, but they're also out of phase in like quantum mechanics space. This one's positively, like you can think of it as positively charged, although that's not really right. Like positive a number, and this one's a negative number. And they're also, importantly, not the same out in the vacuum. They're doing completely other random motions everywhere else in space that are totally uncorrelated. It's only here that they're correlated. So these are two totally different contributions to the overall system that don't cancel out. They just form this strange coherent pattern looking thing here. So So x direction here, yeah, Sean. In this case, I've got x and y directions being actual space, and z direction being like the field value. So it's not the real component of the wave function. The wave, this is going to go over a lot of people's heads. The wave function is encoded in the transparency and the color of each contribution to the quantum field. So you look over here, you've got a little red bump that's kind of translucent. It's not very transparent. That is a contribution to the overall quantum field that doesn't have a very high magnitude, and it has a positive phase. In the meantime, here is this yellow one, for example, has a pretty high magnitude and I don't know, imaginary phase or something. And all of these pile up onto each other to make what you would call a particle. This thing in the middle here is a particle. I don't know that any of this will come across in the video. In fact, I have, yeah, so magnitude and direction in terms of quantum, yeah, Alice, I totally am trying to say too many things with one graph, but I don't really care if people who don't get it. Well, I mean, I want people to get it, but like the main point of this video is particles are actually waves, and all this like actual all this like physical detail is for if you're sort of, I don't know. I think I probably will make like a big making of video on this one that tries to explain it and maybe make it a little more like scripted, because it's really hard to get the ideas down. And I think I might need to like 3 blue 1 brown style do a whole bunch of different different sort of sub animations to get people to the point where this makes sense. Yeah, this is a one particle state on the plane. I did one, I think I did a render at one point at an earlier stage that had 2 particles sort of interacting, but no, I actually didn't. I don't have that functionality yet. Yeah, so this is what I've been working on. You know, it looks pretty cool. Like when you see it all together, like this is just the cross section, right? That's a pretty cool like particle. You know, you can see that it's a particle and also that it's a wave. And like this, like the boson part is really mathematically accurate. Like this is, although it's cheated a little bit in the animation, this isn't entirely what is going on. Like this is a pretty one-to-one correspondence with the math. With the fermionic case, I worked for like 2 months trying to figure out a purely mathematically consistent. I still don't think I've got it. I have a feeling with fermions some really weird things happen with the phase where it's actually more like a bizarre checkerboard type thing. You get into things, if you've ever looked into staggered fermions, for any of you who are physicists, Sean, I'm looking at you. You will see what I've been working with, but it's a headache, and I'm not sure I understand it. And I feel like at this point, I'm gonna fake it a little more on the fermion side, because like I know that the point I'm trying to make about like bosons sort of being analogous to analog, to like an analog like fluid space, and fermions being analogous to a real like digital space, that's coming through clearly. And I think any more mathematical rigor would actually obfuscate that point. All the colored lines are various superimposed phases and amplitudes that one particle's location in the plane. No, you got to stop thinking about things in terms of particles having locations. So this whole thing is a particle, but none of these represent the particle's location, or the particle's amplitude, or the particle's phase, or the particle's wave function, or anything like that. There is no such thing in this view, at this level of resolution, as a particle wave function. Um, what there is such thing as is a field. Um, the field is the field is waving throughout space like a guitar string, wobble 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 wobble. Um, and it like you would think of in usual quantum mechanics, where you have a particle at different possibilities of points in space. This field has different possibilities of in wave configuration, and the wave function of the field is a whole bunch of those added up, the same way that you would think about the wave function of a particle as a whole bunch of locations of the particle added up in, like with weights and phases and stuff. So think of, like, you could think of this field as existing in a huge parameter space, right? Where like there's a dimension of the space for every point of the field, which would be like an infinite dimensional space. But the wave function of the quantum field is a wave function on that infinite dimensional parameter space of all combinations of possible wigglings of the field. And this is taking that like hyperdimensional wave function and trying to collapse it onto the actual like physical space by superimposing all of those different those different configurations with weights and phases, so that you can actually visualize them in a reasonable way. Um, does that make sense? Like, there's the thing is, if you zoom out a level from this and you like treat it as a particle, then this sort of does become the wave function of the particle. This is like, if you sort of look at the top here, this is broadly speaking what your wave function for your particle is going to look like on the plane. You're gonna have it it's gonna have a hump of probability mass here, and it'll have like stripes of phasing. This is something like a wave packet, right? Moving forward. But that's, like, you can see all the detail that you're losing by taking the particle wave function picture, right? Because this is all the information you get about a particle wave function. It's kind of like summing up all of these crazy different amplitudes at every point, and just looking from the top and asking, like, what's the overall contribution from all of them. Then you'll get this kind of like, okay, well, here, like, there's a whole bunch of red, and here there's a whole bunch of yellow, and here there's a whole bunch of blue, and like we can, it's got roughly a circular shape. But the field is doing all these like intricate things within that, and the particle wave function doesn't capture that at all. But this is what a particle, we think, really is, or at least is one representation of what a particle really is. Yep. Okay. So all that. So okay. Now I don't even know if I'll get to working on stuff in the stream today, because I want to show you stuff. What did I want to do? I wanted to show you, Raphael, how I make this. And here it is. This is a graphical language within Blender that you can download called animation nodes. You will, I'm going to speak to you, Raphael, for a second. You probably know about nodes within the shader of Blender, right? For textures and stuff. Like within the shader, you understand that in terms of like, it's a mathematical sort of graphical language for like feeding properties into different filters, so you can get really cool combinations of effects and lighting and color and stuff. This is called animation nodes. So what this does is, hold on, maybe, you know what, demo time. Also, this will be a good warm up for me for getting back into the swing of things. New general. Hey, look, it's the cube. There's modeling nodes. How do modeling nodes work? Tell me about modeling nodes. That sounds interesting. Let's, what do we want? Animation nodes. When do we want it? Now. There we go. Okay, so I got this cube, say. Let's make a new node tree. Let's turn off auto execution, or at least just change it to when we change the tree, the frame, and the property. There are some great tutorials. I've got a there's some really good animation nodes tutorials on the web if you want to start playing around with it. What are we going to call this? My cubes. Okay, what are we going to do? Let's put in, okay, let's put an object input. Where are we? Woo. Come back. Okay, we're going to take this cube. We're going to start with, we got this cube. So now we're telling animation nodes, hey, look at this cube here. I want to do something with it. So we're going to input this object into our system. And now what are we going to do? I keep forgetting the names of this. Luckily, there's nice things that you can do. Grid mesh, is that what we want? No. Matrix, what is it? Create matrix list. No, that's not it either. That's the problem. So one of the problems with animation nodes is that there's so many different nodes, and they all have such similar names that I can't remember which ones. Matrix, compose, replicate matrix, shear matrix, transform matrix, object matrix, input, into matrix. Oh, what is that? What was that thing? Well, okay, let's do a simple example. Let's just do transform matrix. Okay, so first we need to get, so the matrix is what is an attribute of the object. It basically encodes where it is and how it is, how it's rotated and all that stuff, and like its size. So object attribute input, I think. No, that's not it. See, this is why I gotta work better with these things. Object matrix input. Is that it? Yeah, I think that's it. Okay, so now we've got our objects. We've got our object. We're gonna grab its matrix. So basically, it's position data. Let's also make an object matrix output. We're gonna feed that in there. We're also gonna tell it it's this object. So the same object, like once we've done something with with its matrix, put that matrix back into the object and then feed the object out. So now we gotta do matrix. What is it? Matrix math? Maybe it's matrix math. Maybe I don't want matrix. Maybe I just want transform. Yeah. Object transform forms input. Yeah, I don't want the full matrix. I just want the. Okay, new plan. Object is going to go here. We've got its location, its rotation, and its scale. So those are easy to work with. Object transforms output. So now we can put the, we can get this object over here. We can also move that up there so it's out of the way. Get around you. What are we gonna do? Let's change its location. I want, you know what I want to do? I don't want to fully change its location. I just want to add a component to it. I want to move it along the x-axis, say. So let's take its location data and let's what is it? Vector combine what is it? Combine vector. It's the opposite of combine vector. Decompose vector, is that it? I know what I want to do. I'm not sure how to do it. animate vector, combine vector, create vector, vector math, scale vector, subtract vector, vector to Euler, combine vector, separate vector. That's it. Separate vector. We're going to get its location. We're going to separate it into its three components. Now we're going to just make a number, a float input. Let's input float. This will make sense in a second. This is just a number. It's how you put numbers in here. You just, I can slide it along. Yeah, I want this number to be 2.5 or whatever. Let's make that number 0 so it doesn't change anything. We're going to add numbers. We're going to take this x and put it in here. We're going to add, put it there. And then here's what we're going to do. We're going to combine that vector back again. The result's going to go into x. We're going to keep the y and z from before. We're going to feed that back into this location. This location goes back into the object, and we output the object. So if I've done this right, hey, look at that. Whee! Ooh, oh, I know. I have made a mistake. I have made a mistake. Interesting. But you get the idea. The problem is that I made an error. See, what this does is that it takes the object's current location and it adds this number to it. And it does that every time the frame changes. The problem with that is that, or every time the value changes right now. The problem with that is that if it's at 5 and then I add another 5 and then I add another 5 because I'm changing this slightly, it's going to go way off into space. That's not what I want at all. So you know what? Forget this additional math. We're just going to do this. There we go. Whee! Now I can move it around. So the thing that's fun about animation nodes is that you can do things without keyframes. So say I don't want this to just be a float. You know what? I want this to be time info. We've got the frame number here. So then this will be the actual frame number from the animation. Put that in there. Now we can hit play. Whee! Off it goes. Say I don't want that to be. Say I don't want that to be like just going in a straight line. I want it to be a sine wave. Do that. Do that. Hey, look at that. Boink, 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 boink. Now I've got this thing waving up and down like a sine wave. Say I want it to be, let's forget the sine wave. I want it to be an arbitrary expression. Expression. Frame as input for x. Let's do 3 times x cubed plus 2 times x squared, or I don't know what this is going to do. Minus 2 times x squared. There's no squares in here. I think there might be a method of doing squares, but I just do x times x or whatever. Minus 27 times x plus 4. I don't know what this is going to give me, but I can plug the result into there. And then see what it does. Does it do anything good? Oh, we saw it briefly. Where's it going? I think I made it too extreme. Wherever it went, I don't know where it went. We can take that result if we think it's too extreme. Let's multiply it by something real small, and then maybe we can keep track of it. Oh, it's still super small. Okay, let's put it by like 0.001. Let's see what we get. 0.001. Geez, still really heading off into space, isn't it? What can I do here? Oh, hold on. Yeah, I guess I made a function that just like grows, doesn't it? That's not good. Sine x times x plus cosine of x. Multiply that by 1. No. That's doing some weird motion, isn't it? Maybe that's too much. Maybe I want to slow that down. So I'm going to do multiply out here. Give this something where I can stretch time a bit. Make it go real slow. Oh, still going super slow. What are you doing, man? Oh. Oh, yeah. Because I put a square so it gets faster as it goes. Bring that way down. It's one wiggly cube. Right? Tis indeed. Now, we don't just have to stick to cubes, do we? Let's delete that cube for a second. Delete. That's all gone. We got rid of everything. We're going to make ourselves a... How do I add a mesh thing again? Hey, Raphael, what's the the thing for add mesh? Shift left key to go on the first frame. Oh, that's a good trick. Shift left. Okay. And shift right to go on the last frame. Shift A. Yes, there we go. Let's make a grid. How big of a grid? I don't know. What does it look like right now? Let's make it 30 by 30. Cool. Sounds good. What does this look like right now? Right now it looks like that. We'll add a wireframe modifier so we can see it better as a grid. Wireframe. Whoop. There. Now it's a wireframe. Woo. Now let's do some stuff with this grid. I like this. I like this grid. So we'll do input, our object input with the grid. We'll get this grid here. What do I want to do? I want to get mesh. How do I get the mesh off of this thing? Mesh. Object mesh data. I think that's it. Yeah. Put that in. So now we get the mesh. Mesh is the locations of all of the vertices and edges and faces in this object. We have access to all this data in animation nodes. Here we got the mesh. Here we got just the vertex locations. Here we got polygon centers. Use world space. I don't know what that means. Let's do, what do I want to do? I want to take the vertex locations. And I know what I want to do. Okay, we're going to make another expression. First we're gonna break apart, separate that vector. The cool thing about this is that it automatically does like see if I plug in just one vector into here, it'll just do one vector. But if I have a list of vectors, there's a whole bunch of lists in here. So this vertex locations here is a list of vectors. And if I plug that into this node, it just handles it like a list. It's like, okay, you're gonna do a list thing, so I'm gonna separate it into a list of X's, Y's, and Z's, and now we've got a nice list. Cool. Okay. Now, what do we do? Let's see if we can get this to work without making any loops, because I don't like loops. Loops are annoying. But I think maybe we can do let's put this in as x, this in as y. We're going to do, oh, and then let's get the time again. So we'll do time info. So the frame, put that in as t. And then we'll do, I don't know, what should we make this do? X, we're gonna do like a wave packet thing. X minus x squared minus y squared. But like, I don't know, all over. I don't know. That might be enough. I'm not sure what the scale of this is. I think it's actually pretty small. So I might actually have to do times 3 on that. Times sine of x. Let's try that. Oh, sine of x plus t. We get some time in there. I think this is gonna work. I think it handles all these correctly. Like it just outputs. I don't know. We should see what this outputs actually. How do I do that again? What is the key for putting in visualizer? Maybe I can just do it. What are those called again? I can't remember. Well, let's just go ahead and see what it gives us. Do you all work together in music, physics? No, we don't. None of us really work together, as far as I know. Yeah, let's see what happens if we try to combine a vector. It might give me an error. I might have to do this in a loop if I wanted to do this. Combine vector. Okay, we're gonna keep the x and the y. But this is gonna become our new z. Oh, wrong output type. Expected float. Okay. Okay, fine. Damn. All right. Can I like? How do I sever connections? That's not what I do. I don't remember how I sever connections except by going like this. Okay, how are we gonna do this? Did I figure out a way to do this before without a for loop? I don't think I did. I think I required a for loop to make it work. That's all right. Let's make a little subprogram. Loop input. We will call this looping over vertices. We're going to do a new iterator. It's going to be a vector list. Yeah, vector list. So we're gonna put in. So here's what we're gonna do. We're gonna put in our vector of like all these vertices. So each like this is like a bunch of different locations of these vertices, and we're gonna input them all into a loop that loops over them one at a time and does something to them. So we got vector input. Do we need any other inputs? Now we can do time from inside the loop. Put the time info in here. Oh, we need an output. New generator output vector list. So whatever happens to these vectors, they're going to go over here. And what's going to happen to them is we're going to separate them off. We're going to take this. We're going to separate them into their components. We're going to go get that expression. Oh, did I delete it? I deleted it. Okay. Go get the expression. We're going to put in x. We're going to put in y. We're going to put in t. We're going to call it t. I'm going to do something similar to start. We're going to do sine x plus y plus t. Cool. The result is a float. So we're going to combine vector. Yes. Combine vector. We're going to give it the old x and y, but we're going to give it z based on what we did in this expression. And then we're going to put that vector back in here. So now we got a little subprogram. This isn't doing anything yet. It's just a little subprogram that takes in a list of vectors. It looks at the time. It changes the y component of the vectors to be this. It puts that y component into a list of vectors along with the x and y we had before. It returns that vector, and it loops to the next element of the list. So now we've got the next element of the list, and does the same thing, ends up returning an entire list of vectors. So now, here's what we got to do. We got to put in that subprogram, looping over vertices. Okay, vertex locations, loop over those vertices. We don't need this anymore. Yeah, Blender is very friendly for programmers, but I'm not a very good programmer. And like I was trying to do this with like the Python scripting, and it's a mess, at least as far as I can tell. Yeah, you can do regular code. Like there's a scripting tab in Python. And you can also, the cool thing about animation nodes, and I've done this a couple times, is that because the problem with scripting is like, while you can, like the cool thing about Blender is that every time you do an action, it'll actually show you in the scripting tab, here's the Python code we ran to do that action. So like, if you want to do, it's got like a whole bunch of like Blender specific libraries, but if you want to do coding, you can go and like get this mess of code for whatever it was and like put it into a function and everything. But I tried that and I just got like, I don't know, I got bogged down with, I'm really bad with syntax, and I feel like after my code is about 10 lines long, like I lose track of what I'm doing. So the cool thing about animation nodes for me is that like it's really visual and I can tell what I'm doing. But also if I need to break out the full code, there is a node for that. It's called script. So I can write a script and send inputs into the script and then get them out again and do stuff with them. So that's how I've chosen to do this, because like, I don't know, even though this would probably, like in this case, this would be simpler to just write a little script. For one thing, like actually figuring out what the object parameters are called to get into like meshes and vector and locations, and like how the lists are compiled, and like what data types they are and all that, like it's annoying to me. Whereas this does it all itself, so it's kind of like baby programming. But I really like that I can, like at a moment's glance, look at this and say, okay, like what exact data is feeding into what else? And if I want to change it to a different thing, like I don't have to figure out what that variable was or where it is. I'll just, I don't know. I like graphical programming. It suits me. It's definitely slower than like if you really knew what you were doing in Python. It's definitely slower than that. In any case, what do we want? Combine mesh, I think. Yeah, combine mesh. We're going to put this vertex locations in there. Now we need to get the attributes of the old mesh. Mesh info. This mesh. Because we still need to know where its like edges and vertices and polygons are. So we're going to get that. Put that back in. That's not going to change. Take that mesh. Mesh output. Take that mesh. Put it back in here. We're going to take this object put it there. And hopefully, if we've done it right, boink. Aha! Look what we've done. We made it a little big, I think. See what happens if we press play. Woo! Cute. I mean, obviously, you could do that with just a wave parameter in Blender, right? But I am not constrained by any particular. I now have this nice little expression, and I am not constrained by anything that Blender thinks that I ought not be able to do. So I don't know. Let's start by just making this more reasonably scaled, because clearly this isn't working out. We're gonna do 5 times this whole thing. There. I get a little more waviness, but it's too big. So we're gonna do times 0.1. Now we're down here. Now we just got nice little wiggles. Wavy chips are better for dipping, indeed. It's like editing in Photoshop with versus having predetermined filters. Yeah. Say I want this to be x squared. Oh. Now what does it do? Now it's weird. Oh no, that's x times 2. Whoops. X times x. Hey, what the hell? What are we even doing now? Okay, I want to slow it down though. 0.2 times t. Still too fast, I think. 0.05. Hey, look at that. Isn't that pretty? So this is how I've, yeah. All the time, just look at the chat. So this is how I've chosen to do this. Just because it gives me a much fuller range of possibilities for how to animate my quantum fields, and much more mathematical than just chilling with it. Okay, I want to show you something else cool. Let's pause that. Say I want a bunch of these. Object instancer. Put this object in. Let's say I want copy from source, copy full object, deep copy. Yeah. We're going to make 5 of them. Boink. Hey, look over here. Now all of a sudden we have 5 new objects. I don't want 5 of them. I want 25 of them. And then what I want? Grid mesh? No, that's not what I want. I don't want grid mesh. I want matrix list, combine matrix list, translation matrix, rotation matrix, matrix transfer matrix. I can't remember what that node is now. Compose matrix, create matrix list. No, it's not create matrix list. It's not combine matrix list. What is it now? I can't remember. Maybe it doesn't have the word matrix in it. Animate matrix, mix matrix list. It's not grid. Maybe it is grid. Grid mesh. Maybe that's how I did it before. Grid mesh. X divisions 10, Y divisions. See, you can do. This will work, I guess. You can do 5, 5. I mean, the problem is that you want to see a bigger part of it. Oh, I should have. Yeah, I mean, yeah, we can do that. We just got to. What do we got to do? We got to Yeah, go into edit mode. Select all. Create. Scale it. Oh, no, that's not what we want. I don't have the right grid selected. Might be getting confused with the wireframe. I'm going to turn off the wireframe for a second. Whoa, what did we do? I don't know what we did, man. Something strange has occurred. I mean, we just make a new grid, right? We just delete that. All the grids are gone, but all the stuff is still here. So let's yeah, let's make a new grid. Mesh grid 30 30. Yeah, let's do 30 30. Let's make the size bigger. Cool. This right now has nothing plugged into it. This is all just useless now. Let's get rid of all those. Delete. Yeah. That dude. Oh, what happened here? Ah. Something strange is occurring. Oh, I'm still instancing all these objects. Let's bring that down to 0. Yeah, the problem is now I didn't really make the mesh fine enough to see what's going on. But if you go back here. Huh. We could always subdivide it. But doing it, yeah. I would have to make it. I would have had to make it more more detailed for you to really see it, what it's doing. And we can adjust that by changing the height of this thing. That would help. 0.5. Oh, now that just makes it spiky. That's what that does. There, that's kind of an interesting look. We could shade it smooth, and that would help it look less. Not really, actually. I mean, you can make, yeah, you can shade it smooth, but there's only so much you can get from that, I think. Also, oh shoot. Actually, I think there's because if I shade it smooth, yeah, okay. But then as soon, yeah, there's a thing I have to do in animation nodes to get it to shade it smooth again after every on every iteration. Whoops, that's not what I want. Delete. Yeah. Yeah, it's just within animation nodes. If you don't put it in animation nodes, then it like resets on every frame because it's sort of reinstancing the object every frame, so it forgets about smooth shading. Yeah, and then you can put like a subsurf modifier or whatever, right? So that'll go along for the ride with all these things. Right, subdivision surface. Wee. Viewport 2. Wee. Nice. I mean, it's like with the subsurf modifier, it's not actually doing the math on all the subdivisions. So it's like you're gonna get these weird effects unless you actually do it super, like in wireframe mode, it's still Yeah, like it's still doing the math on like on the rough objects, I think. But yeah, but you can always subsurf it and then bake it sub bake it like apply the subsurf modifier so it's there forever, and then do work on that. Um, the other thing you can do in animation nodes is like like the smarter way probably would have been to actually just create the grid within animation nodes, because you can like create a grid mesh, right, and then like instance an object, and then in real time I could like, the way that when you create something you have to like tell it how many divisions it has at the start and then you lose it otherwise. In animation nodes you can sort of bypass that by having it like live create the object, and then you can have sliders that adjust how many divisions it has and where it is and all that stuff. So yeah, so that's a cool little thing. And then if we wanted to, let's see what it looks like right now. Right now it looks kind of boring, doesn't it? Let's let's make this look a little better, shall we? Let's give it a material. Material 1. Should we open shading? That's kind of nice, except I don't want that. That's fake. What should we do? Should we make it metallic? Make it blue. Oh, I don't know. Give a little bit of emission in the blue. Want it to have a sheen? I don't know. It's your thing. Let's keep it white. I don't like the. Let's make it more metallic though. Metallic. I don't like the emission. Turn off the emission. Let's give this thing. We should give this thing a backdrop, shouldn't we? Add. Mesh. Plane. Scale you up. I'm gonna grab this one. Am I in wireframe mode? Yeah. Okay. No, I'm just in wireframe mode though. I'm not in edit mode. There we go. Okay. Grab those. Extrude them up in the X. Oops, not in the X. Extrude them in the Z. Was it Shift B? Or was it just B? How do I bevel? There we go. Oh, weird. That's not what I wanted to do. How come that didn't work? Maybe I beveled once already. Interesting. I don't know why it does that. Hey, you remember how to bevel edges? I'm trying to do this, and usually it makes a nice bevel, but for some reason right now it's got a. Did I extrude it twice and then it like messed with it? EZ. Yeah, it's doing something weird. Maybe I might have made like extra vertices somehow. There we go. Make a nice little bevel. Joink. Hey, that didn't work. Ooh. Okay. And then this one, we're just gonna. Whoops. Okay, that works. Goink. GZ way up there. Hey. And then we're gonna take all this. We're gonna scale it in the X. Yeah. And then we're gonna shift it down in the Z a bit. now we've got, I don't know. This is just, I always do this just because the tutorials showed me how to do it, and I was like, oh, that's a cool effect. And the Y out to there. So now we got this thing going on. And I'm gonna do this here lamp. Let's make it pink. Because why not? And then we're gonna duplicate that object, move it over here, make it blue. Look at that. Trippy. Shade that smooth. What the fuck? That's not smooth. That's the opposite of smooth. I think I did something weird. Ooh, pretty. Let's bring that down. Yeah. So like, it's just a cool, you know. It's a fun tool. Now I got this weird thing going on. What else do I want to do? Oh, I can show you a cool demo with the yeah. Let's add a meta ball. You ever seen a meta ball? Meta balls are cool. Okay. We're gonna give the meta ball the same no, we're gonna give you the same material as the planer. We're going to here's what we're gonna do. We're gonna input an object. Object input. Input that meta ball. Yo. Meta balls were developed for Carl Sagan's program to show how like particles interact and stuff. So what we're gonna do? We are going to object instancer. We're gonna put in this thing. We're gonna instance a bunch of objects. How many? I don't know, like 15. Now we've got 15 meta balls. They're all so far they're not doing anything. But now let's what should we do? Object transforms input. I know I don't need input. I just need object transforms output. So we're gonna specify. You know what? Let's do it just to get so we can. I don't know if we're gonna need this, but let's do it. Locations, rotations, scales. Then we're gonna do object transforms output, and then we're gonna do a wiggle. Vector wiggle. Ahem, ahem, ahem. Oh, do I have to put this in? Oh, I'm gonna have to put this in a loop. What happens if I put the seed in there? Get length? No, that doesn't work. So what if I put the scales in there? Get length. Yeah. Might have to make a loop input vector list loop output vector list. New parameter time again. We're gonna do more time info to get the time. We're gonna get that wiggle back. Vector wiggle. Seed will be the index, so they all have different seeds. The evolution will be the frame. Speed is 1, that's fine. Amplitude 555, sure, we can always adjust that later. We're going to take that. We're not even going to care about the initial vectors. They're just to give us the right thing. We're going to do vector out. Then we're going to do it's just called my loop still. Let's call it wiggle things. Wiggle things. Wiggle things. Here we go. Let's put in the locations. We get a vector list out. We're going to have these as possible changes. Put the objects into there. Going to put the vector list into there. Hey, we got a whole bunch of objects, but they're not visible. Why are they not visible? That's interesting. You can see now my objects are moving around, interacting. However, for some reason, they are invisible. Why is that? Hey, Raphael, any idea why my objects are invisible? What if maybe it's one of these? Ah, there we go. Copy full object. Woo! Okay, now we're gonna hide the original metaball. Oh, never mind. Can I get away with that if I don't deep copy it? No, I can't. Okay, it's all right. We'll just move the original metaball out of the way. Down below. Whoa! Look at that. Okay. I mean, obviously, these things are now interfering with our designs, and also they're too big. So we can make them smaller. Just put in what is it? Combine vector. Made all those 0. Whoops. And then we'll just put a float input. Set that to X, Y, and Z. So we can make them. Oh, interesting. Float. There's too much wiggle going on now. Let's reduce the amplitude of the wiggles. Splot. So that's kind of cool anyways. Metaballs on top of wobbly lasagna. Indeed. Another too low. Let's add vectors. Let's just raise them up a bit. And there we go. Some wobbly lasagna. And some balls. Because why not? It's alive! Woo! Think of this original metaball. Can I resolution? Let's make the resolution a little. Yeah, I want to make them more fine. Yeah, metaballs are cool. They're like they're basically computing like, yeah, they're like these points where they're computing a kind of an equipotential surface based on how many points are in what location. Meatball wave function. So I think I'll probably end up having use of metaballs at some point in this animation, although I haven't quite figured out how yet. Take that off. Yeah. And then you can do things like, okay, well, this is where my camera is. So that's where the camera is, but maybe I don't want the camera to be there. Maybe I want the camera to be somewhere else. So where's the camera? How do I see the camera? One thing I don't have a really good grasp of right now is like how to move objects effectively. For example, even like grabbing stuff. Sometimes it does weird things where I'm like, I don't know what cursor I got right now. It doesn't seem to allow me to grab things. What's going on? You know, I got this, I got this, I got this. Sometimes it just gets stuck, it seems. I'm like, now I'm on this. What do I do? Have I got the camera? Now I have to resort to like grabbing it with this type thing. It's very odd. Strange things are going on. Because this is supposed to be the camera view, right? So for example, you can take this camera and like, yeah, like something strange is happening. I'm not sure why. I don't know why. Okay, there we go. G, move it around. See, I can move the camera like this. And lock it to a particular thing. Move it up. Move it this way. Move it this way. Move it up a bit more. Zoink. See, now I get like a good like side profile shot. I think this is boson. Not sure. No, this is nothing. This is me messing around. This is me literally just like not wanting to do work and showing you how this stuff works. There we go. Animation nodes. I can also do stuff with the camera. Like I can get the camera to move around in particular ways and stuff. But you can do that without animation nodes too. Anyways, that's what that is. That's how animation nodes works. This has all just been a demo. We haven't really done any production. I just wanted to show you stuff, but that's okay. Because it's got me thinking about animation nodes and reminding me of like how it works. And that's useful, so I can do this without messing up something really important. You know what? This focal length is too big. Let's bring it back. Pull it back. Oh, wide shot. Zoom in. How far can we zoom in? As far as we want. Anyways, this gives you some idea of the power of Blender, and also of like, you know, if you want to make cool Blender things, I would recommend. Let's see. I'm gonna find the dude. Just so if you want, you can follow him. Learn this stuff because I've mostly learned from like this one guy. Hey, it's ACS Live watching now. Animation nodes, Chris. Yeah, Chris P. This guy's name. This tutorial here is basically the one that we just saw. You just saw me do with with instancing the meta balls. So yeah, if you want to go and learn a bunch of stuff about animation nodes, Raphael in particular, Chris P, great teacher, good little series of tutorials. Yeah, visualizing real world data, Blender, physics, animation tutorial, pillow fight, etc. Yeah, I look forward to seeing your strategy play out. Burr, sir, close the door on your way out. Are you guys having problems with my audio? Is it popping? Is it popping in and out? Please tell me that you can hear me. Okay. It seems to be Valeria's problem. Cool. Well, we're gonna stop that. Yeah, what are we gonna do? We are going to. Hey, look at that. Should we sing about science? Did I just avoid doing any actual work? I think I avoided doing any actual work. Yeah. Oh yeah. Oh yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about. Hey, there's one thing today you should know. You should know about creation of a black hole in the center of the galaxy. Going around it, stars fall inside, and that's why they compound it. They got lots of gravity, moving really fast. Oh, watch out, they're gonna kick your ass there. Just like that. What do I do? Today there was a Nobel Prize. The thought of it will shock your eyes. Oh, it was given to 3 different physicists. What are their names? There was Penrose. The others I didn't already know. It was Gez and another with a similar name. Whoa. It was Penrose that discovered long ago. General relativity predicts black holes. Schwarzschild had seen it but theorized different things. The other were the 2 that found the black hole in the center of our galaxy now. For that they all get $1 million. What luck, gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, I thought it was necessary to go back to sing about science again. It's been some time. We're gonna sing about science. Yeah, we're gonna sing about. What else should I sing about though? We're gonna sing about science. Yeah, we're gonna sing about. Is his name Roberts? Maybe it is. Is Robert a silly name? It's none of your biz. Oh. Gonna sing about science. gonna sing about science. We're gonna sing about science. Oh. Yeah, we're gonna sing about. Nathan wants me to sing about every type of plane. I don't know any types of planes, you may think I'm insane. I couldn't tell you the difference between an AF-26 and a fighter jet. A C-17, I don't know what you mean. I don't know what that is if it ain't an F-18. Oh, there is too many planes, SR-71. Oh, having lots of fun with the Cessna Prop 1. What? Oh, I don't know what to tell you about planes. They go up because the air goes down the wings. They go down when the air stops going up the wings. They go down when they stall cause of turbulence, separating the flow from the wings. Oh, that's not very good. Please don't stall your plane and crash. That wouldn't be very fun. Sing about meatballs. Oh, what should I sing about them? They're very tasty, but they are made of animal flesh. Someday I'll be a monster in the eyes of history, 'cause I ate lots of cows when I was only 23. And also now, eventually we'll be seen as monsters by the future, when the future is reduced to all the lab meat that's ethically made. And people will have arguments about the ethicality of eating stem cell derived meat, the same way we have arguments now about embryonic stem cell research. But till then the meatballs are tasty. Oh, did you say metaballs? Oh, I suppose metaballs, yeah, I could sing about that too. But meatballs are more fun. We're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. Oh, we're gonna sing about the life on Venus. I don't think that I have seen it. That's the best drop. Thanks. See, there's this thing called phosphine, and it's really hard to create. Reacts with everything, so it disintegrates. So Sarah Seeger said there would be signs of life if you pointed a telescope at atmosphere inside. And then people went and looked at the clouds of Venus, and what did they see? They saw phosphine. A genius said that, hey, that means maybe there's life over there. It's 10,000 times more powerful than we could have compared with how we thought phosphine would be. So now we are filled with glee, and now we gotta wait and see till we get something in that atmosphere. And then we can see if signs of cells exist or not. And if it's some other kind of chemistry, that'd be hot. It's really hot and sulfurous. What can survive, we don't know. But who knows, life finds a way, and maybe it starts to grow. Sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. We're gonna sing about science. Yeah, we're gonna sing about science. Yeah, what the fuck say? Science. What does the fuck say? Science. Yeah, what does the fuck say? Science. What does the fuck say? Science. Yeah, what does the fuck say? Science. What does the fuck say? Science. Yeah, what does the fuck say? Science. What does the fuck say? Science. Yeah. Science. Well, that's our stream. Thanks for watching. Thanks for being along with me for the ride. Thanks for getting me restarted with Blender. It's been some time since I've been there. Now I'm gonna work on it. I did like a deep clean of my place last night. I think I'm gonna continue with my reorganization. So I'm finding some cool things that are making work better, like making this desk down here. You still can't see it, but it's great. And these things. That's something I've been wanting to do for a while. So I will see you back here tomorrow, even though I always find that I like kind of resent these streams when I start. I'm like, oh, I don't want to do this. And then when I get on it, I'm like, this is cool. So thanks for sticking around with me. Raphael and Smith, Mary me, Snelia, Trump's B757 sucks, and Smith, Alan, Metzger, the pipe pump. We got out Atomic J, Iwajessic, Valeria, Souza, Nelia, Amy, of course, Zach, S, full name Sheeran, middle name Danger, and we are signing off from this little corner of the woods. I don't know what we'll do tomorrow. We'll have to see what we do tomorrow. Might actually do production, might do something else. Oh yeah, oh yeah, oh yeah, oh yeah, oh yeah, oh yeah. We're gonna sing about. We're gonna sing. We're going to sing. What are we going to sing about? It's going to be science, ladies and gentlemen. That is the thing that we're going to sing about.